This is a video tutorial for my TouchDevelop curriculum. This is for activity 3, in which we're going to create a breakout clone, also known as Arkanoid or brick breaker, whatever you want to call it. So let's start by going to touchdevelop.com, and we're going to sign in with a Microsoft account. Remember, you can sign in with Facebook as well. I'd already logged in, so that's why it's come up so quick. We're going to create a script, and we're going to start with a physics game starter. You see there's quite a lot of options now, and you should have a play about with them, but we're going to start today with the physics game starter. And I'm just going to call it Breakout clone. You should try and be more original than that. Remember, you can change the icon as well, so if you look through and get a wee ball or something, just whatever you want. Don't spend too long on this. And I'm not finding a good one. I'll just do it that way. I'll do, right. You can change the colour as well. Okay, back into this. We're going to make a breakout clone. So the first thing we're going to do is go into the main action, which is the piece of code that runs as soon as the game launches. We're going to leave it as a landscape game board. We're going to change the gravity though to 0, because Breakout is one of those games where gravity doesn't really apply. And we're going to set the background board to black, which looks nicer for this game. So we're going to change that to black. Okay, so there we go. Run that. We've got a black game board. We're going to add some art for the ball, so let's go to the art. We're going to search online art, and you can add any one from the internet as well, but there's already some nice ball pictures that have been uploaded by myself. Okay, so you see there the soccer ball, the Adidas ball, there's different balls there you can choose from. There's a Star Wars one if you want to be a bit different. Have a look through. That's quite nice as well, isn't it? Have a look through and find a nice ball that you want to use. I'm going to take this one because it's copyright free. There we go. You can write a comment there, nice. Right. And we're going to call that ball, being very original. There we go, we've got ball loaded in now. Go back into main, and we're going to add a global variable. Okay, so one way to do this is to hit var, and you actually enter the right hand side of what you're trying to do first. So we're going to do board, and we're going to create a picture sprite by selecting create picture, backspace that need picture bit out, choose art, and selecting the ball that we just loaded in, and that says creating a local sprite variable. Let's make it global by promoting it to data, and then let's rename it. And we'll rename it to ball sprite. Okay. And you should see, if you look down to data now, we've got one called ball sprite. Okay. And we're going to set the width of that, so let's do data ball sprite set width to 25. Now you can set the height as well, but when you're using picture sprites, setting the width also sets the height, so it's kind of pointless. Either do one or the other, because if I set the height now, it's going to resize the width anyway. If I run that, what we should have is a ball in the middle of the screen, as you can see. If I hadn't done that line, if I cut that out for a second, run it again, you see the difference. That's the default size. So let's undo that and put that back in, and there we go. Okay, we're now going to create an action, a separate bit of code to fire the ball. So we're going to plus here in the code bit, and we're going to rename that by clicking on go. We're going to rename that to fire ball. I'm going to add in 2 parameters by clicking down here, and I'm going to click on them and rename them to X and to Y. Okay, because we're going to pass into this action the positions that we want the ball to fire from. Then in here I'm going to say ball sprite set position, and we're going to say X and Y. Now, if you are using multiple balls, you would probably want to have a parameter here for sprite as well and use that instead so that you could pass in the sprite you want to fire. But since this game only has one ball that fires, that's all you need. We'll just directly access it. But if you want to reuse it, it'd probably be an idea to pass in sprite as well. And we're going to set the speed, and we're going to set that randomly. So we're going to say on the x-axis we're going to say math random 400. Now if I left the ball like that, what would happen is it would travel to the right all the time between 0 and 399 basically. So what I'm going to say here is 400 minus 200. Because that first bit generates a number between 0 and 399, this now gives us between minus 200 and pretty much 200. Actually, if you wanted to make it correct, that really should be 401, because that will give us between minus 200 and 200. But it's a really minor difference, to be honest. In the notes I left, that's 400. Okay, and then on the y-axis, we're going to say minus 100 to begin with, because we want to make sure it goes up the way. We're going to fire the ball from the bottom, so we do not want it going. We do not want it going down the way. Minus is up, and then on top of that, we're going to subtract a random number as well. So if you select math random, and we're going to subtract another 100. So basically, we've got between minus 100 and minus 200 pretty much. Okay, what we're going to do now is we're going to fire the ball. Okay, we're going to go into main now and we're going to fire it. Right, so we're going to say code fire the ball, and we're going to start by firing it from board width divided by 2, which is the bottom, which is the middle of the screen, and on height we're going to say board height, which is the bottom of the screen, and that's it, because we're going to fire it from the bottom. Okay, so if I run this multiple times, we should see it comes at different, you see, comes in at different speeds, but it goes out. Right, what we want to do is we want to stop it going out the three sides. So we could use if statements to do that like we did in Pong, but you can create obstacles in TouchDevelop. So if I do board, we've got something called create obstacle, and we specify here x, y positions. We specify the length of the x and y as well. So what I'm going to say here is 0, 0, which is the top left hand corner. I'm then going to say board height, so board width, thought I was wrong, board width, because we want it to be on the x-axis, we want it to go right across the top, and on the y we're going to say 0, so that pretty much the line's almost invisible, and 1 is how much it bounces. We're going to keep it as 1, which is full bounce basically. Okay, so that's where it's got 1 across the top. So if we fire that now and it hits the top, there we go, that's at the top, it bounces, but we're still going at the side. Okay, so let's add obstacles for the sides as well. So create obstacle. It's good as you're doing this to kind of test it as you go along like I'm doing. Right, this one we're going to start again in the top left hand corner, but it's going to be along the left hand side. So we're going to put the width as 0, and we're going to set board height, so it's basically down the left hand side. So we fire that again. Now we got lucky there. There we go. Right, but again, if it happens to go to the right, there you go, it's going to go out. Okay, so let's make one along that side. So if we do board create obstacle, and this time we want it to start over on the right hand side, so we do board width, and like the last statement, the y length is, sorry, the x length is 0, and the height is, the height of it is the height. Okay, so that's going to now put lines across the top, the left hand side, the right hand side. Okay, and the ball will now bounce off all three sides. If we can get it going that way, you'll see. There we go. Right, but again it goes at the bottom. Now we need to leave it going at the bottom. That's why I didn't just put boundaries around the whole thing, because we need the ball to be able to leave the bottom. Otherwise we can't lose a life when we're playing the game. Next we're going to add in a bat. So let's start by adding in the art. And we'll look for bat. And there's a baseball bat. Will we use that? Is there anything else? Right, baseball bat. There we go, that'll do, won't it? Yeah, I think that's alright, isn't it? Let's call that bat. Right, so now we've got a bat and ball. Back to main. Okay, we're going to create a user variable. I'm going to show you another way of doing it, which I don't really mention in the notes, but there is another way of adding a global variable. You can go straight to data, you can add one yourself, and you can say user bat, and the type is going to be a sprite, so you can actually set the data type here rather than letting it figure it out. Right, so we've created user bat sprite, and that is in data. Okay. And you see there we've got ball sprite, which is the global one, and we've got user bat. So that's the other way of creating it. And then when you go into main, you don't have to hit var, you can go straight to data and you can say user bat equals the board and create picture, art and bat. Okay, so that's the other way of doing it. So user bat. So we've loaded that in, we're going to set the width. I think I've missed it, haven't I? Set width. And we're going to set the width to 100. If we run that, we should have a bat in the middle of the screen. There we go. Right, but we don't want it in the middle of the screen, do we? We want it down the bottom. So guess what? User bat, set position. And where we want to put it is on the board width divided by 2 to put it in the middle, and on that side we want board height to put it at the bottom, but we want to bring it up slightly from the bottom, so I'm going to take 80 off. I want to leave a little bit of room because we're probably playing this on tablets or phones, and you want a wee bit of room for the user to put their finger on and still be able to see the bat. Okay, so that gives a bit of room here for the user to put his finger and move it back and forward, which is the way we're going to control it. Okay, so we've added that in now, and then what we're going to do is fire the ball. So we're going to say code fire ball. And where we're going to fire the ball is going to be from where the user bat is. So we're going to say user bat X and fireball from user bat Y. However, we want it to come from the top of the bat, so we're going to bring the distance up a bit. So we're going to say user bat Y minus, this is where it gets slightly complicated, user bat height divided by 2. Right, and that gets us to the top of it. However, the position of your sprite is the middle, so if we fire it from there, it's a bit hard to see there, but it actually will be firing, the ball will start half in. Right, if I turn the speed off, you would see what I mean, but it's starting kind of half in the bat. So we actually want it, as well as firing it from there, we want to actually take off to get it exactly sitting on the top of the bat when it goes. We want to have it from where the bat is minus half of the height of the bat to bring it to the top of the bat, and then to make sure the ball is also just touching the bat, we want to subtract the ball sprite height as well, also divided by 2. Right, and now it will fire from exactly on top of the bat. Which is a bit hard to see because it's quick, but that is it working now. Okay. Now we're going to go into game loop. and we're going to add in some simple controls. Now there are different ways of doing this which I'll show you later, but we're going to stick with the method that we used for Pong. What we're going to say is if the board is touched, and we're going to set the user bat position on the X. So we're going to say set X, and we're going to take it out from 0, and we're going to set it to board touched on the X. Board, sorry, it is. I saw it there. It's keep going back. Touch current X. So if the board is touched, we set the bat based on it. So now if I use the mouse to simulate that, you see, by holding the left button down, I can drag the bat back and forward. So we've now got user controls in. That code though may give you bother because of the boundaries you see here. Alright, and now, yeah, see there it's gone up the top. That's really doesn't happen on a touchscreen because you can't touch outside the board. But it happens on a PC, so to avoid that happening on the PC, what you can say is if the board is touched and the board touch current X is greater than 0 and the board touch current X is less than the board width. Right, so basically what we've added to that there is to tell it to only allow this to happen when you touch within the board. So if I touch out here, nothing happens. But we now can't get that case where the bat goes right out. Okay, that avoids that problem, which you probably want to do since you're going to be most of you are probably going to be testing this on a PC in school, I'd imagine. If you're doing it on the touchscreen, you really don't need to bother though. Next we want to respawn the ball, so when the ball goes out the bottom we want it to come back, which is the watch at present it doesn't. It just flies out the bottom and doesn't come back, which is not what we want. So what we're going to say is in game loop, because remember game loop repeats while the game's running, we're going to say if the ball sprite on the y-axis is greater than the board height, which means it's gone out the bottom. But to make sure it's gone fully out the bottom, let's add on to that the height of the ball, because if you don't do that it'll basically go only half out before it respawns. And then what we're going to say is fire that ball. Okay, now this code is the same as we did in main pretty much, so let's just copy that out. Save ourselves some typing. Okay, so we're firing it from the bat, same way as we did at the start. So if we play it now and the ball goes out, it should respawn. And watch as well, if I move the bat, watch what happens when it comes back this time. You see, so it's firing from the bat, you can see that quite clearly now. Okay, next we want to make the ball react when it hits the bat. So in game loop, if you go to if again, and we're going to say if the user bat overlaps with the ball sprite, then what we're going to do is say ball sprite, set the y speed, which is the up and down vertical speed. So we're going to say set speed y, and we're going to set it to minus because we're going up the way, but we're going to make sure that we don't get any errors and to make sure it goes up the way, and trust me, errors do happen if you don't do this. We're going to say math absolute, and if you don't know what absolute does, it takes the value of a number and makes it positive, whether it was positive before or not. So it forces it to be positive, and then by putting the negative in, we're forcing it to be negative. So basically what we're doing here is forcing whatever the speed of that happens to be, the ball happens to be, whether the y speed is positive or negative, we are forcing it to go negative, right, so that the ball will go back up the way. There we go. So we've got some basic collision detection in, and we're now kind of ready to add the bricks, aren't we? However, in the game of Breakout, there was kind of special game physics, a bit like in Pong, and basically it depended on what part of the bat you hit it on. Basically, if I hit the ball about there, the ball actually should go to the left. It's so that you could aim it. It's not very realistic physics, but that was the way it worked. So I'm going to suggest you go to library. Okay, so we're going to add in a game library now, that and there it is there. Now you should be able to search for it, but we want to add in the game events library that I wrote and add that to your libraries. And this will let us do more Breakout style collisions. Okay, so if we go back now to the bit here where the ball overlaps, and we're basically going to take that out, and we're going to place it with this. We're going to say var, and we're going to say libraries. We're going to use my game events library, and we're going to use the bat collisions library. What we need to pass into it is the speed of the ball. So we're going to pass in the ball sprite, speed x. We're going to pass in, we're going to pass in the ball sprite y speed, and we also need the position of the ball, so we're going to pass in the ball sprite x and the ball sprite y, and that basically returns two new speeds, an x and a y, a new xy speed for the ball. So what we're going to pass, what we're going to say now is ball sprite set speed using those new variables that I've created there, which is new speed x and new speed y. Okay, I've got a feeling I've done something wrong there, but let's try that and see. Oh yeah, I knew there was something wrong. Right, I did a mistake. The last variable there is wrong. Right, yeah. It's, if you look there, we're passing in position 1, position 2. It's the x position of the two different things that are colliding. Okay, because we're not concerned with the y really, because we know we're bouncing up and down. So that should be the ball sprite x, and it should be the user bat x. Right, the thing needs to know where the bat is. Okay, that should do it. So we're giving it the speed of the ball, the x coordinate of the ball, and the x coordinate of the bat. And now what we have when it comes down is, if I hit it on the right hand side, it goes right. If I try and hit it in the middle, it goes kind of up and down. If I hit it to the left, there you go. Right, so we can now control the ball. There you go. See, it's quite smooth actually. Quite like that a lot. There you go. So you can now aim the ball, which is kind of useful in this game. Right, now let's get some bricks in. First, let's add the art for the bricks. But we'll create a sprite set first actually. So we'll go in here and we'll say var board create sprite set, and we will rename that to bricks, and we'll promote it to data. Right, and we're promoting it to data, makes it global. So we've now got our global bricks sprite set. We'll go into art and we will search for bricks, and I'm not sure what one to use. You can do more arcadey ones if you want to use these, or you can choose one of the real brick pictures here. I think I feel like being arcade style, so I'm going to take the nice blue brick there. But any of those bricks would do. And in the notes I think you'll find that I use a different one, and we're going to call that brick. My names are original, aren't they? Right, back into, sorry, we're going to create an action now. which is going to create all the bricks for us, and we're going to call this add bricks. You want to make sure that the names of things are quite easy to understand. We're going to add in 2 parameters, and what the parameters are going to be are rows and columns, and we're going to leave that as a number type by default. You can change that, by the way, just click in there, you can choose the variable type, but numbers is what we want. So we want to pass in the number of rows, number of columns of bricks that we want. We're going to start here by saying bricks clear, which removes any existing sprites from it. We're going to set up some variables that you can change. You could make this parameters, but I'm just going to do it here. And it's a bit random number, but it's because I've tested this before and that's a nice place to start the bricks at. And I'm going to rename that to first X because that's the position of the first brick. And we're going to do 80 for this one, which, as you maybe guess when I rename it, will be first Y. So this is the X and Y position of the first brick. I'm going to make a variable for spacing. Right, and this is going to be the spacing between the bricks and the X axis. So I'm going to call it X spacing. And we're going to do the same with this. We're going to have the Y spacing at 20. So on the Y axis we're going to space them out by 20 pixels. Right, and now we're going to use for loops. So we're going to say for rows. Right, so this is going to loop round for the amount of rows that we've got, and we're going to do for here, and we're going to say columns. Doesn't really matter what this variable name is. Okay, so rows and columns. Rows is X, columns, sorry, rows is on I and columns is on J. But you could change that if you want, but we don't really need to. Right, so we're going to say var. We're going to create a temporary sprite, so board, create picture, and each sprite is going to be based on the brick that we loaded in. So go to art and choose the brick. So we're creating a temporary sprite there. You can rename that if you want, it's not really necessary, but we can call this brick sprite, and this is just a temporary local sprite which we're going to add to the, it's not actually temporary, it exists on the game board, so as soon as you do that, it's created on the game board, but it's not part of the sprites hit yet. Okay, so then what we're going to say is, if we can find it, so add a line, and we're going to say brick sprite. We're going to set the width to keep them all the same to 60. Again, feel free to change any of these numbers and have fun with that and see what you can do. Then what we're going to say is brick sprite. We're going to set the X position. This is the bit that's a bit tricky. So we're going to start the position as X, but we're going to add on to it, and we're going to use brackets here to make sure we get this right. Inside that we're going to say J times, and we've got more brackets. I'm doing the doubles as I go along to save me messing it up later. And it's brick sprite width plus our X spacing. So we're setting it, the brick space, the brick position on the X axis is starting at first X, which is 108. Added onto that, we're doing J, which is the column number, times the width of the bricks plus the spacing. So if the brick was 100 wide and the spacing is at 5, that's 105 times J. So the first brick will be 0 times 105, which should be 0. So the first brick will be 108. The second brick will be 1 times 108, so it'll be 108 plus, sorry, it'll be the width I should have said, right, so let's start again. The width of the brick, if we go, is 60. So 60 plus X spacing, which is 5, is 65. So the second brick, which is actually brick number 1, because it starts at 0, will be 1 times 65, which is 65, plus X, first X, which is 108, means 173, and so on. The next brick will be 65 along, and the third brick will be another 65 along, and they'll be spaced out like that. Okay. If we then say as well on the y-axis, pretty much the same idea is set y, and we're starting at first y plus bracket, bracket. Inside there we're saying I this time times bracket, bracket. And we're saying in there bricks by height plus the y spacing. I may have overdone the brackets there, but I like to be careful that I know what's happening. And then finally we say bricks add the brick sprite, and that adds it to the sprite set. So go into main, go to the very bottom and say code add bricks, and we're going to add in, you can make this whatever you want, but I'm going to say 4 rows and 10 columns, and hopefully if I've done it right, there we go, bricks have been a success. Okay, and you can easily change now the sprites, you can change the number. As I said, you can now use that and make as many as you want. Let me see, or as few as you want. You could add another few columns, but again it's not really set for that. You see that one's gone out. So you'd have to go in and change the start position if you do that. So finally I'm going to put it back to 4 by 10. Okay. Right, what we want to do now is we want the bricks to disappear when they're hit. So let's do that. I'm going to show you the other way of making an action. So I'm going to go into game loop, I'm going to go right to the bottom, and I'm going to do the coding here first, and then I'm going to create the action. So I'm going to say 4, or I'm going to say 4 each. Right, 4 each. And the only sprites that we have is bricks. So for each E in bricks, so basically each sprite in bricks, okay, you can say if E overlaps with ball sprite. Okay, and that will tell us if any of the bricks hits the ball sprite. You can, if you want, by the way, you can click on this E here, by the way, and you can rename it. So I could rename that to brick sprite if I wanted to. Right, you can do that. I haven't in the notes, but just showing you can. So for each brick sprite in bricks, if brick sprite overlaps the ball sprite, then do. And what we want to do there is, first of all, we want to remove the brick sprite from the brick set because we've destroyed it, and we want to also make sure it disappears off the game board. So we also want to say bricks delete, not bricks delete, sorry, we want to say brick sprite delete. Right, in the notes, if you're looking at notes, I left that as E, but I'm using brick sprite, sounds better in this example. So we've done that. Okay, let's call that now. Now I've actually put that in. If I run that now, that'll work. There you go. Now, really, I think this should be a separate procedure though. So if you highlight that, like I've done there, okay, you can then extract it. So we're going to call that check bricks and extract it, and that calls it automatically, but it also separates it into its own method here, its own action. Sorry. Okay, run that. Still works, and that's just kind of got a brick breaker game. Some of the examples I've seen in the Windows, in the TouchDevelop marketplace, this is pretty much what it does. But for those of us that remember the original Breakout, that is not the way it's meant to work. Right, the ball is meant to bounce back off the bricks. Okay, and we're better than that, so let's do it. We're going to have to, one of the problem with TouchDevelop and a lot of the games development tools is they don't really check for collisions, they check for overlapping. And we don't want the ball to actually enter the brick before it bounces back, we want it just to touch it. So what we're going to do is we're going to add in 2 variables here. So I'm going to say var, and we're going to set it to ball sprite x and we're going to add another variable which is going to be ball sprite y, and that gives us two variables that hold the existing xy position of the ball. But I'm going to rename that to ball old x, because it's the old ball position. I'm going to rename that to ball old y. Right, and that basically now those variables are going to be used to hold the old position of the balls. And we're going to check bricks, and this is where it does get slightly complicated. This is probably the biggest bit of code we'll do for this game. So up here I'm going to make a new local variable called a boolean, which we're going to call hit. Right, and that's meaning has a brick being hit. Right, now pretty much when the brick is hit, what we want to say is hit equals true. Okay, and then if you come outside, now you need to make sure you hit this move left, because I want to be right outside the for loop here. I don't want to be, if I was one line back, I'd be inside the for loop, and this would be running multiple times. And what I'm going to say is if not hit. Okay, so if the ball doesn't hit any of the bricks, what we want to do is say, in fact I'm going to copy this in the main bit, okay, except I forgot to make them global. Right, make sure you make them things global. Right, and then I'm going to just copy these two lines. I'm going to mark it there. I did that a bit quick, now let's do it again. Click on the line you want to copy. See this over here where it says mark? Click on that and pull that down. Copy that. Go into check bricks, down there, and I really think this was a long way for a shortcut. Anyway, we're going to do that. We're going to set the old position of the ball based on where the brick is where the ball is when it hasn't hit a brick. So continually, as long as the ball isn't hitting the brick, any of the bricks, the ball has another position stored. But when it hits the brick, we don't store the position. That's so that we know the last position of the ball before it hits a brick. And what we're going to do is this. What we're going to say is we're going to change this and this whole bit basically, right? So inside here we're going to add in collision detection. We're going to add in collision response. So what we're going to say is if the old ball position before it hit the brick plus ball sprite width divided by 3. Now I actually did have it divided by 2, but this seemed to work slightly better. We're basically trying to say if the ball here is hitting on the left hand side, so if the ball's x position is less than the middle of the ball's x position plus the width divided by 3. The reason it's not divided by 2 is because the ball is circular. It could hit on any corner of the ball, and although this side here, if the corner of the ball would be half by divided by half, the ball's circular, so divide by 3 gives a kind of better, it's just better, trust me on this. Right, and if it's less than brick sprite x, so it's if it's to the left of the brick, minus brick sprite width divided by 2, and the brick is square, so that's fine for that. That gives us brick sprite x minus brick sprite width divided by 2 gives us the left hand side of the brick, and basically we're saying if the ball is to the left of the brick when it hits it, and if it is to the left of the brick, what we want to say is ball sprite set speed x to minus, a bit like we've done before, math absolute, forcing it to go to the left, and it's the absolute of the existing ball sprite speed x. Okay, and if we run that to check, and what we need to do is get the ball hitting from the side, so let's try and do that. Right, you see that it bounced off that brick from the side. Okay, now I'm going to actually copy that because I think it'll speed things up a bit, so I'm going to put a new line in there and I'm going to paste that in, and I'm going to change the next line to if ball x minus the third of the width is this time greater than or equal to brick sprite x plus the width to get to the right hand side of the ball. So we're basically saying if the left hand side of the ball is greater than the right hand side of the brick, then we want to set the ball speed to positive. So take the minus out and run that now, and you see the ball is now being directed left and right when it hits the bricks. Okay, I'm still going to copy that even though this one is a bit more to change. Right, so the next one we're saying not ball, we're saying the old ball position, the Y this time, plus ball sprite height divided by 3 is less than or equal to ball sprite Y minus the height divided by 2. And in this case we set the set speed Y to be negative of the Y speed. Let's try that. Right, on the way back down, there we go. Right, it's catching it from above. And if we copy that again, paste it in, and this time we say minus the height, so we're now checking the top of the ball, which is maybe the one we should have done first, I guess. And what we're saying is if it's the top of the ball is greater than or equal to the bottom of the brick, which means it's actually below it, because remember down the way is positive, so the brick plus the height, then we want it to react by going positive, which is down the way. Okay, and there we go. We now have some decent collision detection between the ball and the bricks. And we're very close to having Breakout now, aren't we? Okie dokie. Right. We're going to have a new action here called new level, because when we clear a wave of bricks we want a new level to spawn, and what we're going to say in there is add bricks. In fact, I'll just type it in. I was going to copy it, but it's hardly worth it. So 4 by 10, and I suppose you could increase this number as the waves go on. Right. Okay, that's that. That's all we need to do for new level, is add the bricks at current anyway. We might add more to that later. Back into main, we're going to add some other things we need for the game. Right, we need lives, so let's say variable equals 3, and we'll rename that to lives, and we'll make it global. Whoops, let's click on that and make it global. Right, we also want to have score as well. Let's add that in, so variable 0, and we'll make that, rename that to score, and make it global. We're going to add in a sprite, so variable as well, a sprite for the to actually display the lives. I'm going to say board, and it is create text. We'll leave it to the default position and sizes at present, and we'll call that, we'll rename that to lives display, and we're going to make it global, and we're going to say lives display, we're going to set its position to 6, 4, 5, which is near the right hand side, and 10 down from the top. We're also going to add in a text sprite for the score, so let's rename that to score display, and we'll make that global as well. Let's cut that and put it, it doesn't really matter, we're going to put that underneath here to keep it all together. So lives, the live display, score display, and lastly for this wee bit we want to set the score display set position, and we're going to make it 125 by 10, which is a wee bit into the left and 10 down from the top. Okay, and let's cut this line. Actually, if you look at the notes, I actually said to extract this, but I'm going to cut that one and put it down here. If you look at the notes, I did just say to extract that into a separate one. But if you forget to do that like I did, just cut and paste it down. Not cut and paste it, cut it out. Because what we need to say instead is new level. Okay, which does the add bricks. But since we're probably going to add other stuff into new level, let's do that. Okay. Right, and then to check bricks now. And more in here. When it hits the brick, another thing we want to do is say score equals score, you've guessed it, plus 5. Again, you can make it more if you want. And we're also going to say if, this is quite a handy thing about sprite sets, you can say the name of the sprite set and you can count to see how many sprites are left in the sprite set, and if it equals 0, then yep, you guessed it, new level. Okay, and that will respawn the bricks when we clear them and give us a score, which is always good. We need to make sure we can see this score though, so let's go into the game loop, and at the top what we're going to say is score display. We're going to set the text in the score display, and we're going to set it to say score, and we can concatenate onto that the actual value of the score, which is held in the score variable. And pretty much we'll do the same thing for the lives display. We're going to say lives display, set text, take that out, we're going to set it to lives, and concatenate onto that and the lives. Okay, good time to run it. 5, 10, 15 and so on, as you can see. So game is working. Okay, what we now need to do though is also check to see when the ball leaves the screen. So if we go back into game loop, if you find the bit of code that was checking for the ball leaving the screen, this is the kind of thing where comments help. So you might want to do this at various bits, is put comment and say I guess refire is not a real word. Let's see, put comments in is useful. I'm bad at commenting, so try and be better at me. Let's do lives equal lives plus 1. So when the ball, sorry, not plus 1, you want to get a life when the ball goes at the bottom. Make that minus. Right, so when the ball leaves the bottom of the screen, we refine it, but we also take a life off. And in there, since that's the only place in this game you can lose life, let's say if lives equals 0, then end the game. Except I forgot to put the end game method in, so we'll come back to that. Go into here, make an action called end game. And when the game ends, we want to use the bizarre leaderboard. So we're going to say bizarre post leaderboard score, and the score that we want to post is in the variable that we called score. But we also want to display this on the screen, so we're going to say bizarre post leaderboard to the wall. Right, and we're also going to say game over, and we can post that to the wall. Okay, and finally we're just gonna say time stop and stop the script at that point. Right, so if we go back into here, we can now say end game. So when the lives reach 0, we end the game. So if I quickly miss it 3 times, right, the game ends and it says game over and your score comes up on the leaderboard. If you publish it, you'll get a proper leaderboard scoreboard there. If we run that script again, to test this properly, probably shouldn't waste the video doing this, but you should find if you run through now and clear the bricks, what you should get is that the bricks come back. And it is quite easy to do though now because I haven't added something which I'm going to add in a second. I'm going to just test it. I'm halfway there anyway. Show you my breakout skills. Exciting, I know. Whoops, almost missed it there. As you can see, the collision detection isn't absolutely perfect, but it's pretty good. Right. I mean, the collision detection is fine. It's collision response that I wrote that isn't exactly perfect, but it's pretty good. Right. Oh, 1 brick to go. Oh, David, come on. Seriously. There we go. This is easier with a touchscreen tablet. There we go. And that was quite a good way to hit it because you see I'll clear about half the bricks there. Right, now as you might have noticed, it's quite easy at this point. So one thing I would highly suggest you do is set it so that the ball gets faster and faster as the game goes on. Right, because otherwise you'll be here forever, as you can see. And you want to make your game as challenging. So we're going to go into game loop. Right, so let's go to game loop. And anywhere in here at all really. Doesn't really matter where. I'm going to stick it, just put it at the end. Right, so we're going to say, I'm going to make a variable for this so you know how to change it, and we'll say 1.0005, which I'm guessing is, I've chosen because I've played a bit with it. And this is going to be the acceleration of the ball. Right, and to do that, what we're going to say is ball sprite, and we're going to set the speed based on the existing speed. Right, so if you just do it this way first, set ball speed to ball sprite speed x, and on the y we're going to set it to ball sprite speed y. Okay, so we're setting the speed of the ball to the speed of the ball. But if we now go into this and we say times acceleration, and then there say times acceleration, and the reason I made this number just slightly over 1 is because it will basically only very gradually increase it by 0.0005 every time, because we don't want it to speed up too quick or it quickly becomes unplayable. And then we'll say ball sprite, just to make it a bit nicer, let's finally make this ball spin. We probably should have done this earlier. Set the angular speed, and we'll set the angular speed of the ball based on the ball sprite for horizontal speed, which is x. You could do it on the y as well, but I'm going to do x, I like that better. And run that, and the ball now spins, which is always good. And hopefully we'll see when it will start to speed up and make it slightly more difficult. I think you probably should be starting to notice it is increasing. And by the time I get through this, if I manage to do it without losing a life, it is going to be rapid. When it respawns, the speed will go back though, so it shouldn't be rapid forever. There we go. And as you can see, it's starting to get quicker. Because I'm amazing at Breakout, I'm still managing to clear it. That's one of the challenges, to get as good at Breakout as me. How good I'm at this. Right. I won't bore you with my skills. I'm going to let myself dine out. And see if you can beat that score. And I was only half trying. Okay, there's some challenges for this activity as well, which is create a background picture, add some sound effects for when the ball hits the bat, for when bricks are destroyed. You might want to change the graphics, maybe use have a different row of graphics, so each row of bricks is a different brick graphic. You could even have a power sprite. I'm not insisting that one's a bit tricky, but you can have a power sprite that drops when you destroy one of the bricks, that either decreases the speed of the ball or increases the speed of the bat, things like that. And finally, make it your own, change the graphics and publish a script, and you'll get people playing it. Use the publish option and publish it to TouchDevelop so other users around the world can have a shot of it. And that's the end of this activity. Thank you for listening. Hopefully you can understand me. Goodbye for now.